Alright. Okay, no more silly faces. You got it out your system?
Yes.
No more silly faces.
Did you
Alright.
go?
Hey, it was picture day, so y'all all look nice. Everybody look good? Your hair done? My hair look good?
You got big one.
Your
Yes.
mustache? My mustache look good? Alright, everybody looks good. We ready to do this?
Yes.
Okay. Alright. The cookie fiasco. You know what fiasco means? Fiasco is like one of those fancy words for a problem. You got a big cookie problem. Okay?
Oh.
Big cookie problem.
I read those books.
Oh, these guys? The Elephant and Pig? Well, what this is, Elephant and Pig, they love this book. They love this book so much they said, hey, that is one great idea. Okay? So now, hey guys, cookie time! Everybody's happy for cookies, right? Everybody loves cookies, right?
Yes, give it.
Mm-mm.
Hey.
Uh-oh! Hold on. There are 3 cookies, but 4 of us. Someone will not get a cookie! Uh-oh. What do we have to do, Chris?
Split them in triangles.
We'll have to split them. Hold on. Not yet. Let's see what kind of idea they come up with. Chris says we have to split them. If we split them, what do we need? Do we need different sizes?
Oh,
Hold on. What's the word I'm looking for?
You can do it in equivalent.
We need equivalent. We need equal pieces, right? Hold on. Let's test it out.
Mike, you can do it into these so they all can get. They can get Someone will not get so one. Then they can get both.
We're fixing to check that out, G. I see those gears turning. That's good. That is not fair. We need equal cookies for all. You just said equivalent, right? We know equivalent means what?
Equal.
Equal. So we need equal cookies. That's going to be tough, guys. I have an idea. Maybe you two can share one cookie. Y'all want to share one cookie? Would that be fair? Would that be equal sized pieces?
That would be a disgusting issue. If you do that.
Oh, just because you don't like eating after somebody else?
If they want to share one, like if they want to give me a cookie.
Well, hold on. Well, hey.
I would
Time out. All right. Can I borrow these?
Yeah.
Y'all share one cookie, and hey, me and G gonna eat a whole cookie. Is that fair? Look, hold up your cookie.
No.
And y'all get these. Are these equal?
No.
Is that fair?
This was you talking about
No
yesterday.
way. No way.
You were just talking about yesterday. We didn't have the cookie.
I was talking about this yesterday. Okay, so what? We do not share cookies. We do not share a lot of things. I'm wearing her socks. So is he sharing her socks?
Yeah.
They're kind of silly, the 2 squirrels. I think they're brother and sister.
Yeah.
I heard crocodiles do not like cookies. Maybe you should not get a cookie. You think crocodiles eat cookies? No, you don't think crocodiles?
Yeah, they do.
Look at this guy.
Yeah.
Huh? I eat cookies. I love cookies. I could eat a whole plate right now. What's going? Uh-oh. What is Hippo doing? Snap. Uh-oh. Or we can share by our size. What a great idea. Wait. You are huge. You get all the cookies. Is that fair for Hippo to get all the cookies just because he's a big guy? No way. Oh, really? He knows he's being silly, huh? See him laughing? Snap. Uh-oh, what did you do? Did you hear something? Hippo, what are you doing? I break things when I'm nervous. Uh-oh, what's happening? Everybody freaking out now?
Yeah.
Why? Because he's breaking the cookies?
Yeah.
Snap, snap. Stop that. I'm sorry. You're making things worse. Show us the cookies. Is he making things worse, you think? Why do you say no?
Because he's snapping them in half and they can share.
All
of them.
Yeah. 1, 2, 3, 4, 5, 6. 3, 3. All right, everybody break your cookies in half. We got 3 cookies. Everybody break your cookie in half. So this is where I would ask students to test the theory in the
So-
book.
Break 3 cookies.
No, in half. So there's 3 cookies, right? Look, 1, 2, 3. There's 4 of us. Look, Dylan. There's 3 cookies. So there's 1 cookie. This is 1 cookie right here.
I'm like I'm gonna break it.
And then this is, and then look, G. And then this is your cookies, right? So
Wait,
look.
I'm gonna break it like this.
Hey, Dylan. Look, put yours out here, bud. So, does this look like what they're talking about in the book?
Yes!
1, 2, 3 cookies, right? How many are us?
4!
There's 4 of us.
But 3 cookies!
Hold on. What? Wait, what did Hippo?
They all get 2!
Wait, we have to test this out. Did Hippo just broke all their cookies in half, right?
Yeah!
Alright, Dylan, can you pass these out to everybody? Is everybody going to get an equal piece?
1, 2,
Okay.
3.
You and G. Wait, I only got 2 left.
Oh no!
Is that, oh no, is that going to work?
No! But look back there.
Well, so who gets the extra ones? Me and G?
No!
That's
but
not
look,
fair.
No, we break those in half!
But Mr. Mike, look
We
back
break
there.
those in half!
I
You
get
can break
one.
it up to these. You do these.
Okay.
We break them into We break those in half.
But Mr. Mike, look
We
back
got to
there.
break these in half again?
Mr.
Yeah.
Mike.
Hold on to that idea. We're going to keep reading. Hold on to that idea.
Mr. Mike.
Wait! Now there are 6 cookie pieces, but only 4 of us. So look here. They're showing you up here, huh? Is that equal? Not equal. This is not good. This is not fair. This is not what?
Equal.
And what do we do when we break up fractions? They always have to be what?
Equal.
They have to be equal pieces.
Yes.
My nerves! Snap! What is Hippo doing?
Snapped them in half.
He's hungry. His belly says hungry.
Hold on, time out. Dylan, you said something like that, huh? Did you say we had to break these in half again?
Yeah.
Mr. Mike. No, you can use these because you can break these in half because these are both going to get they're both going to get 1. Well, they're both going to get 3.
Gee, you... We have to solve this problem fast. Our friendship depends on it. Say it. We need equal cookies for all. Because when we break up fractions, what do we need?
Equal.
Oh no! Snap, rumble. Everybody's freaking out. What's Hippo doing? He's breaking them in half again, right?
Yeah.
Ah, stop! The pieces are getting smaller. Gee, you know something about pieces getting smaller.
They mean they're going to have less. They're going to have smaller parts.
Smaller
Like
parts. Smaller parts, but when I have smaller parts, does my denominator get bigger or smaller?
Bigger.
Uh-huh.
Not to me.
They will be crumbs soon. We will have to eat cookie crumbs. This is a flop, a mess, a disaster. It's a fiasco. What's fiasco? That was in our title, remember?
It's like the worst. Like the problem.
It's like
The
the worst
problem.
problem ever. Uh-huh. And they're just, look at how bummed out they are. They're so bummed they're not going to be able to eat cookies, huh?
Yeah. Cool.
Snap. Uh-oh. They
Snap,
can't
snap,
take it.
snap,
Snap, snap, snap. Sorry, I cannot stop. It is what he does. Right? That's what he does, he said when he got nervous, huh? He breaks things in half. He broke all the pieces again. Why is he still holding the cookies? Oh, I'm too afraid to count. Okay. So we have to test this out.
Yeah.
So this is where I'm going to ask the students to test out the theory again. You said earlier, Dylan.
We had to break them in half.
Chris.
Two.
Hey.
We had to break one half, 2 halves. Oh, 2.
2 halves again.
Yeah.
Yeah.
And then you said what?
Because see, he's going to break 2 halves, and he's going to break this. Because see, they're like this. then he's gonna just break them.
All right, so can everybody put what 3 yellow cookies out front? Put the 3 yellow cookies out front. Because if we broke the halves and half,
4,
so
you mean?
the 4s. What do we call pieces of 4? What do we call these? 4.
4 equals. 4
Four
holes.
equal parts.
Not 4 holes. They're 4 equal pieces. What do we call them?
Computer.
Thirds.
4, 5,
4. Right.
4.
Very good.
Your computer
So-
died.
That's okay. I think he's still filming. I think the screen just takes a nap sometimes. Well, let's see. Let's click record again. Okay. Hey guys. All right. So, hey, Chris. If we have all of these together,
Yes.
now, gee, you said something earlier. Before we even check this out, you said how many pieces would we get?
We'll get 3.
3.
Yep.
Gee. Gee, I want you to pretend that you are the hippo, okay? Because Hippo's gonna say something here real soon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's check. 1.
2, 3, 4, 5. 1, 2, 3.
1.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Now there are 12 cookie pieces. But still only 4 of us. So there's still 4 of us, right? 1.
2, 3, 4.
But look at Squirrel's thinking. He's thinking. He's thinking like G was thinking earlier.
No, they all can get 3. That's what I just said.
And then
That's
you
what
throw
G was
away-
saying.
and
Look
then
in
you
the
throw away
hand.
the wax.
Look in his hand.
And 3 and 3.
3 and 3 and 3 and 3.
Yeah.
And then we throw away the rest.
You're gonna be the hippo. Get these cookies away from me, please. Oh boy. Guys, take one at a time. G, can you pass out one piece at a time? Don't forget me. I want to eat my cookie too.
1, 2.
Yeah, look, me. Don't forget me. I'm the 4th guy. I want cookies
Can I
too.
eat this?
Do you have yours? Yeah. Okay. Now keep going again. You want one? Mm-hmm. Dylan?
I want one.
You want one?
Uh-oh, is this gonna work? How many do we have left? Hold on, hold on. Alright, G, you get one? You get one? How many do you have? Don't have that one on me.
3.
Dylan gets one? Can I have this last piece? How many does everybody have?
3. 3.
Now give me my pieces.
Did we just figure this out?
Yes.
Yes.
I have 3 pieces.
I
I
have
have
3
3
pieces.
pieces.
Me too.
1, 2, 3.
No.
Me too.
No,
I'm a
they-
me too, because I love
They
blue.
all don't got 3. Wait, look. Oh, wait.
No, look, that's Hippo,
I
see?
forgot, yeah.
Hippo, big old hands.
Oh.
We did it! Equal.
Cookies for all.
Hippo.
Hippo was the one that
And now what?
solved the problem. Eat.
Munch, 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 munch. Are they
Munch,
enjoying their
munch,
cookies?
Munch,
Yeah.
munch, munch, munch. So many munches.
Oh, goodness.
Oh.
Hey, guys. Milk time. How many glasses of milk does he have?
3.
3 glasses.
How many friends?
4.
Oh, goodness. How are they going to figure that out?
Oh, I know.
They
I know.
did
I
it.
know.
Oh,
They
no.
did the same thing again.
The same thing again? Why? Because there's still how many friends?
They can
4.
like they can like drink a little and the other one.
You want to make one silly face at the camera first? All right. Okay. Oh, you would. All right, you want to fix your hair, make sure we look good? We look good? Y'all look pretty sharp. You fixing your mustache? All right.
My hair growing back.
It is.
I need to fix
It
my
looks nice.
mustache.
Okay. All right. Chris, what do we know about fractions?
Dash. Dash against the
play with the little things and that's you get
Tell me, what does a fraction look like? Is it one whole number, or does it have like a top number, a bottom number? What's
top number,
what do we call the top number?
numerator,
Very good.
and
G.
a lot.
Hold on.
Oh, it's
G. What do you call the bottom number?
denominator.
G. My denominator. What do we call the denominator? What did the denominator show us?
The least number. I mean the biggest number.
No.
Like
The-
the actual number.
Okay. Denominator always has to be what? Bigger than the top number, right? We remember that. If we're looking at a fraction model, what number is my altogether number? Is it the top number?
The denominator.
It's the what?
Denominator.
And so if my altogether number is the denominator, what's my numerator?
Numerator.
What does numerator tell me? Is
All
that
together.
no? We just said my altogether number is my denominator.
Shaded.
Say it again.
Shaded.
It's how many you shade in, right?
And then the other one is how many all together.
And which one do we call that? The
Denominator.
denominator. Very good. G, let me ask you this. This is a tough one. This is a tough one. There was something important about the denominator that we've learned before. It was something about the bigger the number. Say, hold on. The
That's what I was
smaller,
about to say.
the smaller what gets? The smaller the.
Numerator gets.
Mm.
What the denominator gets.
Yeah.
Okay, hold on.
The numbers.
Alright.
The smaller it is, the less you get.
Yeah.
The less you get, the smaller the smaller amount you get, the smaller the pieces. So, what if we had a pizza party, right? What if I cut it into? What if it was just us three? We gonna get 3 big pieces, right? But then what if I keep cutting it into smaller and smaller pieces? My denominator is gonna get what?
Smaller.
The piece is gonna get smaller, but my denominator is gonna get what?
Bigger.
Yeah.
Very good. Very good. Okay. So what I want to do is we have explored. Excuse me, I just burped.
That's alright.
Well, thank you. I know we just had lunch. Red beans are good. Huh?
Yeah, it was so yummy.
Okay. When we read the book Cookie Fiasco, they had a problem, right? It was 4 friends. They only had how many cookies?
3.
3 cookies.
3 cookies. They had to divide those, right? We had to find an equivalent fraction. They had to figure out, and y'all even use the fraction circles, right?
We use these.
Yeah.
Because, well, what did they do first? First they broke them in what?
Like this.
First they broke them, they broke each whole cookie. First they broke it in,
Like this.
what do we call those? And
2 equal parts.
2 equal parts. They broke it in half, right?
Yeah.
And
they
then,
broke it to this.
but then what did what did Hippo do after he broke them in half? What did he do with the 2 halves? He did what?
Took them apart.
Took them apart.
He did what again?
And did this.
And when he broke the halves in half, what size did he get?
This.
What are those? How many?
The 4.
Say it again.
4.
Very good. Hold on, Chris.
Oh.
Okay. So, y'all did a great job testing out everything that they mentioned in the book. Okay. So, what I want y'all to do now, we're going to go through our stations. Okay. Chris, I want you to pick a card first. Okay. Pick a card, and then. Oh, hold on. Once you pick a card, how about you want to do the foam circles first?
No, I want to do it first.
Hold on.
No, he can
Hey,
do it first.
Hold on. Time out, guys. We're all going to take turns. We're all going to go through every one of the centers, okay? Chris, I want you to choose your card first.
I feel like
And
I will
then-
sneeze.
Okay, well just make sure you cover up if you have to sneeze, man.
No, when I like sneeze, I'll turn that way.
Thank you, I would appreciate that. I got plenty of tissues over there.
Thanks.
Alright, once you get your card, hold on to it.
Okay, unless you will go and wait.
Good deal. Alright, put those back in the pocket. G's gonna pick his. Okay? Alright.
I already
And
know
then,
what G goes.
so G, I tell you what, this is what we're gonna do. I'm gonna let Chris go through each station. We're gonna rotate through here, and then I'll call you over here. I'll let you choose a card, and you'll go through all the stations, okay? Now, for a minute, okay? For a minute. Each station is, you have to go through the foam circles. Hold on. You got to go through the foam circles and try and
I know.
listen up for me. You have to go through the foam circles. You have to show me your fraction first, and then you have to show me every equivalent. We got to test every color, every size, every shape. If they're halves, thirds, fourths, fifths, sixths, sevenths, eighths, we have to figure it out, okay? When we're done with the foam circles, let's go to the magnet strips next, okay? After the magnet strips, is that kind of the same as the foam circles? Do they have to equal the same length? Do they have to equal the same size? They don't have to equal the
No,
same
they
size.
do.
They have to be the same size if they're going to be equivalent, right? What if I had a cookie this size,
Yes.
but I gave G a cookie that size? Is that equivalent?
I know, Wayne.
Is that equivalent? No, because they're not equal sizes, right? So look, we'll do the foam circles, we'll do the magnet strips, and then after magnet strips, hold on, Chris, we're going to do the number lines. G, what do you remember about number lines?
The denominator is always gonna be the same. Denominator is always gonna be the big thing.
It
Well,
is.
not always.
What if? Let me ask you this. So if I had 2 8s on my number line.
Oh, if you get this one, if you might get this one.
Okay, if you might get this
might
one.
line up. Wait, they might line
Okay.
up the same.
Well, let's see.
It won't line up the same.
Oh, so are they equivalent?
Yes, sir.
No. Do they have to line up the same to be equivalent?
Yes, sir.
That's what.
That one lines up the same.
Oh, does it?
Yes.
So,
Mr. Mike, I remember when we did it with the
so would those be
Legos.
equivalent?
Yes, sir.
They would be. They have to line up the same. Do they have to be the same distance from 0?
Yes, sir. I mean, yes, sir.
Right? Yeah,
Mr.
not a
White.
drum set.
They're gonna be the same difference, but they're gonna be so that this has smaller pieces, this has bigger pieces. Mr. Mike.
And that's okay. This has smaller pieces. Why? Because my denominator is
Bigger.
very good. That's what I want to see, okay? So hold on. Time out. We'll start with Chris. Chris is going to rotate through his centers, okay?
Mr. Mike, remember when we did it with the Legos, so we had to like do the like stuff for them?
We did Lego fractions.
Can we do it again, Mr. Mike?
All right. Hold on. So,
That's fun.
all right, Chris. So what fraction did you pick?
You talk about the number,
Yeah.
yes, sir.
What is it?
1, 2.
How do we say 1, 2? That
1.
is that third? Is it half? Is it
Half.
fourth? Yeah. Very good.
Half.
Very, very good. What number is my numerator? Hold on. What number is my numerator? Say it.
The 1,
And what number is my denominator?
the 2.
Very good. So, if my denominator, hold on. I want to put this back in the pile first. Look, you can get up. You can get up and move around. If my denominator is 2, how many pieces do I need?
3.
Hey, my denominator
I mean
is 2.
2.
So you need how many pieces?
2.
So what fraction circles,
Without thinking.
which ones is it going to take 2 pieces to make a whole circle? Which ones?
Like a whole circle.
Mm-hmm. But how many pieces to make a whole circle? Awesome. Okay, so that's my altogether number, right? My denominator is 2. That's 2 altogether.
But Mr. Mike, look.
Oh, but Mr. Mike, look.
Shaded 1.
Shaded 1, so how many do I need?
Altogether, we supposed to have like 3. And look.
No, not altogether. We can't add the numerator denominator together. You are absolutely right. My altogether number is what?
2.
But how many do we need to work with? Huh?
1.
1. So let's put 1 back in the pile. And so this is 1/2.
So you cut this one like that.
Okay, we can
And
cut.
it equals this.
Well, hold on. Hold on. Let me ask you a question before we start up.
Okay.
To find an equivalent, it has to be the same, right? Does it have to be equal? Does it have to equal the same? Chris?
Yeah.
Okay.
And I got it wrong. I think it's...
That's okay. There might be more than one answer. Very good. Is that equivalent?
Mm-hmm.
Is it the exact same?
Mm-hmm.
Is there any hanging over?
Yeah.
There's stuff hanging over, or does
No.
it equal the same?
Equal the same.
Equal
Wait,
the
look.
same.
I cut this in a knife. Wait.
Dude, I think that's awesome. Okay? So, hey, let me ask you this. How many pieces?
2.
2. How many of the yellow pieces does it take to make a whole circle?
4.
So my fraction is what? 2.
Equal 4.
2 over 4.
4.
Say it again.
2 over 4.
Very good. Hey, all right. Keep this one stacked up. Keep that one stacked up, okay? Are there more? Will the orange ones work?
Wait.
Will the blue ones work?
No, the orange ones can, the blue ones can work. Look.
I don't know. I'm not taking your word for it. You gotta prove it to
Wait.
me. I'm not sure. You gotta prove it to me.
Watch this.
I'm gonna watch. I want to see. Let me see what you got. Oh, Mr. Chris.
That's right.
It's right. Is it right? It's right because it's what?
All together.
It's all together. Is it the same? Is it the same?
Yeah.
Is it equal? Is it
Yeah.
What's that big fancy word we've been using? If it's equal, it's what?
Equivalent.
Good job. Okay. How many pieces?
3.
So that's my numerator, right? How many pieces does it take all together to make a whole circle? Are those light blue pieces? Here, man. Here, get up. Am I in your way?
Oh, Mr. Mike, look. We can grab this one and look how I make.
Oh, that's pretty slick. So are you telling me?
No,
The-
look, cause look.
Okay.
This and this one make like a line, and this one can fit like that.
That's incredible. So if they fit and they make a line like that, is it safe for us to say 2 4s equals 3 6? Is it going to be 6 blues to make a whole circle? Check. I want to make sure my denominator is
Well,
right.
it will.
Well,
It will.
check for me.
Look, watch this.
Very good. Line them up nice and neat. You're doing fine. Good job, Chris.
Wait, I know something.
You got it. I think you're doing fine. It took 3 to equal half of it, right? I just want to make sure so we know 3 is my numerator. Is it going to be 6 altogether?
I think, yeah.
Okay. Let's test it out. Good. Look, line up that straight line together. You don't want any of it hanging over. Very good.
Yeah, it's gonna be 6.
Very good. So you already, all right, so you checked the yellow one, so we know 2 4s. We know 3 6. Any other ones gonna work? Which ones?
Wait, I think I know one.
Try it out. Try it out any way you want to. Let's see, we tried. Ooh. Hey, can I ask you something? Why aren't you trying the orange ones?
Wait, that'll work.
You think so?
Okay, so watch this.
Remember, it has to be equal. It has to be the same.
It is. Watch this.
Oh, now look, that's pretty smart. Let me ask you this: is just the orange ones going to equal? I don't want to mix them up yet. Okay.
Wait.
Look, try this guy. Hold on. Oh, try just the orange. Is that equal?
Oh, wait, yeah.
Yeah. Hold on. Let me flip this over because I want you to look at this. Is that equal?
Wait, no.
No way, Jose.
No.
That's hanging over big time.
Yeah.
Let me see. If I get this cookie, and you get that cookie, is that equal?
No.
Is that the same? That's not fair, huh? So these don't. Do the orange work?
No.
No, orange don't work. All right, look, you tried
Yellow
those.
will.
Oh, I know. You tried those, right? Try. Which ones have we not done? Try those out.
I think this gonna work.
I don't know. You gotta prove it to me. I'm not sure if it's gonna work or not, bud.
I think this gonna be.
Oh, wait, hold on. Did you fill up half?
Yeah.
How many?
Yeah, it's gonna work.
How many? You filled up half? How many is it?
1, 2, 3, 4, 5, 6, 7, 8.
Wait, alright, so 4 is my numerator. How many
8.
altogether? What's my altogether number?
The bottom
The bottom, you just said it,
equals 8. And
equals 8. 4 over
4
over what?
over. Yeah, 4 equals 8.
4 over 8. 4 over 8. Chris, I think that's
And
awesome.
Mike, guess what?
Huh?
Even if you put like the these on here, it gonna work too.
Oh, it will. And but look, let's test that out. You're saying even if I put these on here, it's gonna work, right? Does that mean that 2 4s and 4 8s are the same? All right, hold them still. You got them? Are those equivalent? Why are they equivalent? Because they're the what?
Oh, Miss Mike, yeah, cause you can like chop this up into pieces like that.
If you chop this into pieces, what size are they gonna be? Are they gonna be that size? Flip it over. How many? Does that work? Put them together, real tight. Does that equal the same thing?
Yeah.
That's pretty neat, huh?
Yeah.
I like that. Dude, you're doing great. Look, let me take your card over here so we don't forget. Let me see you do the magnet bars. Is that cool? Come on, bud. Let's go. You're doing really, really, really good.
You can use that
Alright, Chris. You did the foam circles. Awesome. Give me 5. Alright. You ready for the magnet strips? Alright, so what's your fraction, bud? Say it. 1.
1/2.
1/2. Very good.
Hey, here we go.
Hey, here we go. Okay, good. Alright, so look, can I move this guy out the way?
Mhm.
Alright, I'll move this guy out the way. Alright, so look, Chris, for it to be equivalent, if it's going to be the same, does it have to be the same size as this one? Let's test them out, okay? Cool? Alright, hold on, time out. Alright, so there's the same? Alright, how many?
1, 2, 3, 5.
5. Is 5 my numerator?
Mhm.
Here, hold on, let's write it. 5 over what? What's my bottom number?
10.
Awesome, fill it in for me.
5 over.
Does that one work? You can get another one.
Oh, I know one. This one. 5 over. Wait.
That works good. That one works real good.
5 over 10.
Awesome. Alright, keep on going. I want you to find as many equivalent fractions that you can, okay? So that one don't work?
Yeah.
Alright, talk to me.
10 over. Wait.
No, alright. How many pieces did you use?
4.
4. So is that my top number or my bottom number?
Wait. 10 over 4.
Okay. I see what you're doing, okay? So look. All we're doing, we're just looking at the pink ones, right?
5 over.
No, count them again. How many did we use?
4.
4. Is that my numerator or my denominator?
Denominator. I mean numerator.
Okay, numerator. So what's my numerator? 1, 2, 3,
4.
Write it down over here.
4.
Mm-hmm.
So 4.
Uh-huh.
Oh, that's the way that's not.
Hey, just use the red one. The red one works real good.
Yeah, sure do.
It sure does.
4.
Very good. And then what's your bottom number?
8.
Very good. Awesome. All right, keep going, big guy. I want to see as many as you can get, okay? Look, here. Leave the red one out. We'll use that one. That one's working real good, okay?
Yeah.
Cool. Keep going, bud.
Look, see.
I know. Just leave it, man. Don't be telling him my white boy Buster.
Oh, see.
It's alright. I'll let you slide. Don't mess with it no more, okay? Just leave it.
Look what it's doing.
I know. Just leave it. Just leave it.
Oh.
We're not worried about it. Here you go. I bet there's a couple more. Try them out. I want you to try test all of them.
What? Wait, I know, right?
No, Chris, you're so smart. You are on to something. Alright, what's my fraction?
8 over 6.
Remember. Okay, so we're done with the 8s, right?
1, 2, 3
Over.
over 8. 3 over 1. 3 over.
What's my denominator, Buster?
Oh, 3 over 6.
3 over 6. Very, very good. Record it.
3 over 6.
That's what I
Alright,
call
good,
awesome
though.
sauce. You have some of the best handwriting in class. I'm very impressed. It looks really nice. Hey, that's not a drum kit. Not a drum kit. Keep going. I bet you there's some more. All right, no help this time, Chris. What's my fraction? How many pieces? Good. Ooh, I'm so happy. Good job, man. All right, good job. Okay, are there any more?
Hey.
That looks good. Keep testing. Are there any more?
Yeah. This might work. No.
Nope. Hey, and I got it. Chris, tell me, why didn't that one work?
Because it was too big.
It was too big, and if they're equivalent, they have to be what?
Small.
Well, not small, they have to be
I
what?
mean, like a little big or a little small.
Do they have to be the same if they're equal?
Yeah.
No, hey, you already tried the ace, huh?
Oh, when
What else? Let's see.
Oh.
Oh, let's see if that works. I'll get you, G. That looks good, man.
Mr. Adams, I did so much good today.
You're doing awesome. I bet my college teacher's gonna be very impressed by your hard work, man.
It worked.
All right, no help. Write down your fraction. Last one. Write it down.
I know what it is.
I know you know what it is. Write it down for me. Wait, how many did you?
Wait.
Wait. How many pieces did you use?
6/4.
6 over what?
4. I mean, 4/6.
Hold on.
I mean,
Remember, so we just finished these guys, right? So switch gears, okay? How many pieces did you use? Hold on, can I time you out? Can I time you out? Hold on. Time out, Chris. Time out. How many pieces did we use, buddy? Count them up.
1, 2, 3, 4, 5, 6.
So is that my numerator or my denominator?
No, numerator.
Write it at the top then.
So that's 5,
No, count it
Oh.
again. How many did you get?
6.
Very good. And then what's my
Six.
what's my denominator?
6/4. I
What?
mean,
We're not messing with fours anymore. We're doing
One.
what?
6/4.
Are you guessing?
Yeah.
Look at, I know. Look at your blocks. What's my denominator?
4.
There is no 4 on these blocks.
I mean, 12.
12. Denominator doesn't change, bud.
4.
Alright, good job. Alright. This is probably the toughest part of the station. Can you handle it?
Yeah.
You ready? Look here, grab your fraction, okay? Take that one over here with you. There you go.
Hey, look at it did.
It's okay. I think it looks neat. Alright, so I'll tell you what, move this guy over here so we can see it real good, okay?
You talk to it.
We've been talking to it. It's been hearing everything. The camera even hears when you're being...
it can say stuff.
Well,
when you
it doesn't say
no,
stuff
when-
back to you.
No, when you video it.
Mm-hmm. Alright, so
Oh.
here. Push the phone circles out the way, because we got to do number line now, okay? So, first, ooh, that's a bunch of number lines.
Mike, can I do the Lego shooting?
We'll do fraction Legos later on. I want to do this first, okay? Alright, find your fraction.
Right.
What's your fraction?
1/2. I mean, 1/2.
Very good. 1/2.
So I have to be
1/2.
the first line.
Well, we have to find...
1/2.
Very good. So get that one out. Here, you want?
I'll line it up for you, sweet.
Oh, well, thanks, man. I appreciate it. Here, you want to put your clip on there?
Mm-hmm.
Okay. Now, earlier when we were all in a group and we were working together, G helped us out, huh?
Yeah.
G said, Mr. Mike, they had to line up if they're equivalent. Do you agree?
I do.
I do too. So, can we test each one? Look here. What if I test,
Oh.
what if I test this one? Look, is that equivalent? Did they line up? Do my arrows line up?
No.
No. Equivalent? Nope. Hey, what about this one though? Let's test this one. Did they line up?
No.
Is that equivalent? No way, Jose. You can just put this guy back over here on the side, okay? So look, I want you,
So it has to be the same number?
it doesn't have to be the same number, but it has to be in the same place. It has to line up. It has to be the same distance from zero. Try it out. Let's see if that works.
Let's go.
Sure does. So what's my fraction?
Yeah.
What's my fraction we clipped it on?
2/4.
Very good. So if that one works, pile those up over there on that side. All right. Here's some more clips. Keep on trying. We're not playing with them. Keep on trying them.
So. Four over 8.
Awesome. Good job, man. Are you just lining them up? You don't even have to use the clips?
No.
You just iron them up, huh?
Yeah.
Okay. I'm okay with that.
5 over 10.
Man, you're making this number line stuff look easy, Chris.
It is easy.
Does that one work? No.
No.
Ooh. What do you think about that one?
6 over 12.
Great. Hey, let me ask you something. Hey, hold on. Time out. You just told me this one 6 over 12 works, right? Check your board over there. Is that one that we wrote down?
No.
Look at the answers you wrote down.
Wait. Where?
All the answers you wrote.
Yeah, 6 over 12.
And it works there on that number line too, right?
Mm-hmm.
Hey, let me ask you something. Hold on, time out. Let me ask you something else. You told me, hold on, which one here works?
5 over 10.
Did you write that one down on the board?
Yeah.
Are you noticing like a pattern? Hey, no
Yeah.
helicopters, please. Thank you.
Okay.
Hold on.
3 over 6.
Did you write that one on the board?
Yeah.
I'm liking what I'm seeing, Chris. You're doing great.
That's cool though.
That is cool though, huh?
Mm-hmm.
That one don't work?
Wait, none of these don't.
None of these don't. You're right.
Yeah, I'm right.
You are right. Hey,
Here you go.
give me a good one. Hey, look at me up. Good job, man. I think that's great. I bet my professor's gonna be very impressed. You think so? You wanna wave to him? Say hi?
Where?
On the camera.
Hey!
No, just say hey.
Hey!
Okay. Thank you, bud. Yeah, you can go now. Go ahead, buddy. Can you reach it? You can walk to the other side if you need to. Go ahead. You're doing foam fraction circles first. I'm just getting this one ready for you, okay? Let's scramble them all up. What fraction did you choose, bud?
I choose 1/4.
1/4. So you immediately got the yellow fraction circles. Why?
Because it's 4. It's 4, and you just take out 1, and it makes. Wait. So, and then you just call 1 in. You just shake 1 in, and it makes 4.
That's a good explanation too. So, what are you going to do to find an equivalent fraction?
I'm going to use some glue. Wait. No.
What do you think? Talk to me.
It's not hanging off, and it's the same.
It's the same. Can I ask you? Oh, okay. I'm sorry. I think I see what you're doing. Keep going. Okay. So
This one's a shaded off. Wait. And this one's a shaded off one, and these are the ones that are not shaded off.
okay. So look, G. What I want to know is what fraction is that? Can you explain to me what fraction is represented there? What would be called the foam pieces that you use here? You use 2, right?
They're the numerator.
That's the numerator. What would the denominator be for that fraction? How many of the blue pieces?
I would need 2, 4, 6, 8. I would need 8.
Awesome. So what's my fraction? 2 over...
Over 1.
No, what was my altogether
2
number?
over...
Denominator is my altogether number. You told me that earlier in the group
4.
work. How many altogether do the blue pieces equal? Count them again. Count them again. Did you
2,
just
4,
add them?
6, 8.
Good. So we use what? 1, 2 over what? What's my denominator?
Over 4. Over 8.
Okay, and I see what you were doing because you know denominator usually never changes, right?
Yeah.
But if we're looking for equivalent, we use the smaller 8 pieces, right? So we use how many? 2, but how many does it take to fill up the whole circle? 2, 4, 6, 8. I'm glad you skipped counting 2. So we use 2 over 8, right?
Yes, sir.
Does anything else work?
Yes, sir.
Try it out.
Wait, nothing else works.
Nothing else works for the 1/4?
Well, these
Not quite, huh? It's close.
so then that's it.
And those are too big. And that's it. That's okay. Do me a favor. Let's go check our magnet bars and tell me. Here, you want to clip your fraction up on the clip so you don't forget? Hey, stay quiet for me just for a second, okay? Give it a minute, bro. Alright, very good. So you put your 1/4 at the top, right? Because that's our fraction. Now explain to me, how are you going to check to make sure they're equivalent, G?
By putting them by each other, seeing if they don't hang off.
Seeing if they don't hang off. What's the word I want you to use? What's our word?
If they're
Equal.
Equal.
And you just said it's
Equivalent.
equivalent. Very good. Okay, does this work?
What?
Write it down. What fraction is that? How many pieces did you use?
3.
3. So is that my numerator or denominator? Very good. And we used 3 of the 12 pieces. So what's my denominator then? Awesome. Good job. Great, great, great job. Keep going. You got a good fraction. I don't know how many other ones will work. Test it out for me. Did you just know that was going to work? Good job, man.
8. 2.
Mm-hmm. How'd you know that was going to work? Was that the same as the one you solved on the... It is, right? 2 of the... Let me ask you, can I ask you something else?
Oh, because see, like right here, in the middle of this, see, in the middle of these, it's like these.
Oh, you're saying if you drew this line all the way up, it cut it right in half, huh? You keep going. You're doing great. Why you don't want to use that one?
It's not going to work.
How do you know it's not going to work? Talk to me.
Because it's like much bigger than...
It's much bigger. It's
Yeah.
yeah, it hangs over, huh? So it's not the same length, and if it's not the same length, it's not the same size, huh? I saw you doing the tenths. Did they not work? What happened there? No. What other colors do we need to try?
Oh, I could try 10. Wait, I could try 5. No. That's it.
That's it. Well done. All right, you got one more station to go to, man. You are doing great. Here, you want your card?
Oh, I thought
Hey, give me 1 second. Let me change the camera because I want to film how well you do the number lines too. Is that cool with you? I'll tell you what. I'm gonna move it over here, buddy. All right, Mr. G. Go forward. Talk to me, bud. You have to explain to me everything you said. So look, I know I was just reviewing with Chris because when we were working together in a group, you said something that made a lot of sense to me with the number lines. Do you remember what that was?
okay.
I said, I think I asked you something. I was like, well, how are you going to use a number line to tell the fractions are equivalent? Right? How are you checking? Because I see your brain working already. How are you checking?
By, when it's equivalent, like when I'm doing up there,
Mm-hmm.
so like if it's equivalent, like in they're the same.
If they're the same, that means that they're what?
Equivalent.
Equivalent. Very good. So you did great. You found your fraction on a number line first, right? And so what are you checking? I see you have the number line with 12ths on it. What do you think? They look like they're the same to me.
They are.
They are? Is that because they're on the same spot?
Yes, sir.
Is one closer to 0 than the other one?
No, sir.
No, they're the same, right? What fraction did you clip it on the 12 number line?
I put it on the first one.
On your 12 number line, what fraction did you clip it on here? 1/12, 2/12, which one did you clip it on?
3.
Is that one of the same fractions you wrote down up there on the board?
Yes, sir. It's only going to be that one. That one.
I don't know. Did you check all of them? Look, if you find one that does not work, send it over here so you know you checked it already, okay? Because I bet you there'll be at least one more that probably works. That one works? Let me ask you this. It's the same one on the board. That's awesome. Why do you think there were so few that equaled the same as your fraction? Was your
Wait,
fraction...
Mr. Mike, this is not the same.
You sure?
This is 8, 2 8.
2 8s. You didn't write 2 8s up there?
Oh, I did.
You were looking at the 1/8, right? But how many did you use? You used how many of them?
2.
2. So that's why we wrote 2 8s. Do they all line up?
Uh,
Let me go back. Why do you not have as many equivalent fractions than like Chris had?
Because mine's more bigger number.
Your denominator is bigger, which means that you're what?
I have less pieces.
You have less. You high five. Gee, I'm so proud of you. Good job, man.
Are we done?
We're done for right now, yeah.
Can I get back on harmony?
You can. You only got. Oh wait, go see Miss Courtney first. Go see Miss Courtney, and then if you have time, when you get back, I'll let you. Okay. All right, Mr. Dillon. You wanna wave to the camera? You wanna say hi? You wanna make one silly face, get it out your system? All right. Should we look good? Look good. You're pretty sharp looking, guys. All right. So, tell me. Look. Just tell me everything you know about fractions.
A proper fraction is a fraction where the bigger numbers on the bottom and the smaller numbers on the top, or both the same number.
If they're both the same number, there's something interesting about a fraction that has the same number on the top and
It's a
bottom.
whole.
Great answer.
But
Let me
it's
ask you, what do we call the number on the top?
a numerator.
And what about the number on the bottom?
Denominator.
Very, very good.
And an improper fraction is where the numerator is bigger than the denominator.
Great answer. When we run into an improper fraction, do we have to fix those sometimes? And when we fix them, what winds up happening?
They're proper.
They're proper, and when they're proper, do we have just a fraction, or do we have a mixture of whole numbers and fractions when we fix them?
Mixed.
A mixture. Is that why they call them mixed numbers? It is. That's awesome. Let me ask you this. This is a really important. This was something we added to your notebook, okay? And we put stars and we highlighted because it was really important. It said something like, the bigger your denominator, the what? What kind of pieces?
The smaller the pieces.
High five, man. That's great. Alright, so look, man. Did you like our book? That was a good book, right? So we have our whole math center, and I'll let you pick a card, okay? And once you pick a card, I mean, you can kind of choose which one do you want to do first. You want to do the foam circles first? Do foam circles first? You want me to just grab it, or you want me to just hand you one? All right, now look. You're like my top dog, okay? You're gonna solve all of these, and I tell you what, I got a surprise here at the end of here. It's gonna be tough. You ready for this? Ooh, I don't know. It might be. Did you peek already? All right, buddy.
1/4.
1/4. Very good. So first, well done. Go ahead and explain that to me. Tell me everything that you're doing.
1/4 is 4 pieces. So if you have 4 of the yellow pieces, it makes one whole circle.
Very good. And if our fraction card asks for 1/4, that means
You
that.
only put 1.
Very good. Okay, so what I want you to do now.
So you take away 3, and now it's 1/4.
That's a great explanation, Dylan. You could teach this class probably one day. All right, so now that you've represented 1/4, this is the tough part. I want you to find as many equivalent fractions that you can using the foam circles. Deal? Equivalent. Equivalent was that fancy word that means what? Hey, hold on. Hey, can I time you out 1 second? Equivalent. That was a fancy word, right? Equivalent means what?
Equal.
Equal. Now, if we're dealing with 1/4, what do we need to work with? Now, if it's going to equal or be the same as this, Now you're cooking. Let me see what you... Tell me what you did. Justify your answer. Explain that to me.
If you use 2 of the dark blue ones,
Uh-huh.
they make 1 yellow one. And if you if
So-
you're dealing with a half, you take the pink one, or you can take 2 of the yellow ones, or light blue,
Can I ask you a few questions?
any of the colors except for orange and red.
Let me ask you this. I noticed that at first you tried the light blue pieces. Did that not work?
No, they were too big.
Can you tell me why that didn't work? It was too big?
Yeah, it was too big.
Oh, so you're saying if you took 2 of them, it would be way bigger than my 1/4 piece. Is that what you're saying?
Yeah, like this.
The pink one doesn't work, right? Because it's way too big.
Yeah.
Did you
But
try
if
the...
you're dealing with 1/2, then you can use the pink one, the light blue, this one. Any
Why?
of the colors except for orange and red.
Why not orange and red? Why didn't you use orange or red?
Because they're not equivalent fractions.
Very good explanation. All right, I have one more tough question for you, okay? You found your answer pretty quick. You said, if I have 2 of the dark ones, they equal, or they are equivalent to my 1/4 piece, my yellow piece, right? What's the number of these? What size are these? These are what kind of pieces? Are those thirds? Are they fifths? Are they sixths? Are they sevenths? Are they
I will
eighths?
find out.
Well, thank you, sir.
Eighths.
How'd you figure that out? You only have 4 pieces there.
4. 4 of these make 1/2, and 4 more makes 8.
Another high five. That's a great answer. So if you only needed 2 to equal your 1/4, what would this fraction be?
2 eighths.
Another high five. Great job. So is that the only equivalent fraction we can make with the phone circles? I think so. I don't have any smaller pieces than the dark blue ones. Is that going to be it? You tried the light blue ones, right? You said I can't do orange or red. It's not halves, right? Is that it for right now?
Wait,
No, you told me that's way too big.
with one of
Wait, now can you mix up fractions if we're doing equivalents?
these.
Hmm?
I don't
No, sir. Against the rules.
but it's wait.
I think that's too big anyways, huh? Yep. So hey, here, let's alright, grab your flashcard. Grab your fraction card, bud. You wanna do the magnet bars next?
Yep.
Alright, I'm mix them up. Mix them up. Here, want me to pick it up here for you? There you go, buddy. Alright, so show me your fraction first.
Okay, 1/4.
Alright, now remember, I want you to talk to me. You've got to tell me everything you're doing the whole time to explain to me how a fraction is either equal or not equal, okay? Alright, tell me what you just did, Dylan. Woo. Alright, time out. Tell me what you did. Explain to me those purple blocks.
These are 12s, and like 3/12 make 1/4.
How do you know that? I mean, I'm looking at it, but talk to me a little more. How exactly did you know that?
I don't know. I just tried the purple blocks.
Okay.
And I got 1/4.
Are you telling me that in order for them to be equal or equivalent, do they have to be the same size?
Yeah.
Do they have to be the same length? Like, can it hang over and be a little longer than 1/4? Can it be really, really close but a little bit short than 1/4 and be equivalent? They have to be what?
Exactly the same.
Great answer. What about your ace there? I see the pink blocks.
The eighths, like, 2/4 make 1/8, and like,
Wait, hold on. Say that again.
2/4 make an 8. So,
Two.
So 8.
Do you mean 2/8 make a 4th? Oh, so 2/4.
And
So now you kind of double up. Hey, can I ask you about this? Can I separate these just a little bit? Go back to this one, okay? How many eighths does it take to equal 1/4?
2.
2. Is that the exact same answer you gave me with the foam circles? Are the 6 gonna work? Why?
And they're too big.
Good job, man.
I think that's all.
You didn't try the 5s? What about the 5s? Are they gonna work? Too big. What else do we have to try?
I'm gonna mix.
No, wait. Now, can you mix them if you're doing equivalents? What about the thirds? Doesn't work. I think you did a great job and a good
And
job.
I think that's all.
I think yes, all too for right now. Huh? All the magnets that I have. All right, so Dylan, the last section in the center. Now we did this. Look, we did this in the workbook, okay? And you smashed it. What can you tell me before you even get started? What can you tell me about number lines and a fraction having to be equivalent on a number line? What do you know?
It's kind of like if you have 4 and you're like, what will be equal to 4? And you do this.
All right, well, let's find your 4th first.
4.
Oh, good job.
1/4. And you try and see what's equal to it by comparing two different numbers.
By
Number lines.
comparing two number lines. Dylan,
And 3/12
clip it on there. Now,
are equal to 1/4.
hey, you had that on your magnets up there on the board too, right? Didn't you have 3 other 12 pieces? Good job. All right, hold on. Can I time out? Talk to me about this. Now, I see they line up the same way, right? Are they... What do they have in common with how far away they are from the 0?
They both look the same length away from
Say that one more time.
They both the same length away from the 0.
Are they... What about their distance from the whole?
They're still the
So you're telling me an equivalent fraction of a number line is the same distance away from the 0?
same. And the whole, yes.
Dude, lay one on me. Man, you got some great answers. I might let you be a teacher one day. Now, how did you know 2/8 was equivalent so quick and so easy? The magnets and the foam circles you did, huh? Good job.
Wait.
All right, now I have a bunch of number lines. Test them out.
Nope. Definitely not. Trying the pink one.
Ooh, it's close. Can it be close and be equivalent?
Nope. Has to be exactly the same. That's close, but not close enough. 1/2. Nothing. There's only 3 things equivalent. There's only 3 things equivalent to it.
Are those the exact same fractions that we found in every single center? Wait, 3/12. Well, we didn't have 12s over here, huh? What about 2/8? Did you find 2/8 in the phone circles and the magnets? Did you find 3/12 somewhere? Where at? On the magnets. Good job. You want to separate those? You want to go back?
I already did this.
All right. Well, look, I'm gonna challenge you though. You ready for the challenge? Woo! You ready for the challenge?
What is it?
I'm gonna put your 1/4 back on the board. Okay.
I'm gonna do it like where I end off and then go to where.
Boom.
And go like backwards and then.
Now, what kind of fraction is that?
Forwards and backwards and forwards. 1/12.
1 whole,
1/2.
1/2. Is that an improper fraction or a mixed number?
I think improper.
Now you told me all about improper fractions earlier. You said an improper fraction has a bigger numerator than denominator, right?
Wait.
Wait, Dylan. Hey, time out, time out. Hey. You told me earlier that an improper fraction... Hey, time out, man. You told me earlier that an improper fraction...
Has the bigger number on the top
That's right.
and the smaller number on the bottom.
So does this fit your description? Is this an improper fraction? You told me sometimes you have to fix an improper fraction and you get a what?
A whole.
A whole and a fraction, and they're mixed up. And when the numbers are mixed up, we call them what?
Mixed numbers.
Very good. So I'm challenging you now with this mixed number, okay?
I have no idea how to do it.
Oh, yes you do.
Like one, like you get like one of these, like one of these, and you put it right here.
I got you, buddy.
But you find more that are equal to the middle one. You find more that are equal to the middle one, and you find more that are equal to the whole.
Alright, say that one more time, because I think you nailed it. You have-
Find more that are equal to the middle, and you find more that are equal to the whole.
Does it matter what numbers you use to represent your whole? No. So,
Whatever you put to the fourth.
I think I see what you're doing here. What are you representing with those clips?
The whole.
The whole. And what are you representing with these clips?
The half.
Dylan, I tried to stump you. But you are a very, very clever young man.
See, there's 3 halves, 3 wholes.
And so would all 3 of those combinations be equal or
Yes.
equivalent?
Equivalent. Not equal, equivalent.
That's right. Let's use our big 3rd grade math vocabulary words. Dylan, I'm blown away. I think that's incredible. What do you want to? Which one do you want to do next? Do you want to just work backwards? Do you want to do the magnets next, or do you want to do the foam circles
Like,
next?
I'm like doing this.
That's cool. Do your thing, man.
That's what I'm like. That's what I'm doing.
I got you. I just wanted to know so I can follow you. I wanted to make sure I had you in my camera shot, buddy.
Okay, 1 hole. I'm gonna be using the 8.
Can you do me a favor?
But on 1 hole, you can use the red.
That's exactly what I was going to ask you. Will you represent 1 whole and 1/2 first before you do anything else? Show me 1 whole and 1/2. You want to use the red?
I'm gonna use the reds, all the colors, because there's like multiple of the same color.
There are absolutely.
I'm gonna use all these colors.
You just like talking like a Southern gentleman sometimes. I can dig it.
I'm gonna use all these colors.
You think my teacher will mind if I'm drinking coffee on camera? No? Yeah.
Probably, yeah.
Oh gosh, I need to have the...
Probably because you are grown up.
Oh, so is that okay though?
Yeah,
I bet my college teacher probably drinks coffee in the mornings too. You think so?
yeah.
Okay. So it's cool?
Yeah, it gets you to where you can teach and like do stuff.
No. Well, thanks for the okay.
Because there's like, because the caffeine in it like makes it to where you have a whole bunch of energy where you can do stuff. And you can do stuff that you have to do without even only drinking 1 liquid.
It's a good way to look at it. I just hope my breath doesn't get too stinky like coffee breath. If it does, just let me know, and I'll chew some gum. And what are you doing here, Dylan? Are you representing another hole?
This is the same color. Still trying to get it.
Oh, okay, okay. I got you. I see what you're doing.
Then, red. Now you can use the reds and the oranges.
Oh, you can use oranges?
And the reds too. Now, but if you're dealing with fractions, not wholes, then if you're dealing with fractions, not wholes, then you cannot use the red.
So, hold on. I like what you just said there. You're saying...
But if you're doing a thirds thing, then you can use those.
But the only reason we can use them now is because you're using them as...
Wholes.
Great explanation,
But if
Dylan.
you're also dealing with thirds, you can use the ones.
I got you. I see what you're doing. That's fine. I'll tell you what. I think my professor's going to be very, very impressed.
And
But
also, can you take a picture of this whenever I'm done?
yeah. You want to take like an extra picture?
Like whenever I'm done with all the colors.
Yeah, sure. I'll do that. You know, my teacher friend was very, very happy to see us using those highlighters she donated to us. Remember the picture I took of you that day with the highlighter?
Yeah.
She was happy to see that.
We were using them?
Yeah, those really cool
And
three-color
also,
highlighters.
these are 6.
Those are 6. How do you know that? You only have 4 of them out there.
1, 2, 3. One side. 1, 2, 3.
Gavin, I owe you 2, right? I'm very impressed. Very impressed. Gavin, finish that paragraph you're working on there. And I'll get you set up and I want you to type it. Is that okay? Good deal, man. That's great. Look, as soon as you finish that paragraph, okay?
Take a one.
The one you're working on now. Finish that one up.
I'm done.
Okay. Well, here, you want me to get you set up to type? Oh, do you remember where to go? You do? Good. Show me what you got. All right, so you have a hole represented with every color, but where
You can't use the thirds.
you can't use the thirds.
You can only use the thirds if you're doing a whole or thirds.
Good job, man. I think you're doing great. Now, can you do me a favor when you're setting them up for our picture and for the camera? Will you make sure that you put your whole and the half together? That way you're representing the whole and the half as one number together. You know what I'm talking about?
But how do you put it together?
Well, I mean, just kind of like that. That way that way you see how it looks kind of the same. One whole on here, and then my half there. Does that make sense?
Yeah.
Thanks, bud.
And now we can't use the reds or orange
Oh, why not?
because they are
We can only do those to represent what?
thirds or wholes.
Or the wholes. Good job, Gavin.
So there's two that won't have.
So you want to just push those over to the side? Because we can't represent a half with those, right?
Yeah, but we can still have a kind of rectangle.
Oh yeah, absolutely. Okay, look, can I ask you a question real quick? Let me ask you this. I'm going to get a little close up too. What I'd like for you to explain to me, Dylan, is, can you tell me, let's start, how about with the light blue colors, okay? What would this improper fraction be? How many of those 6 pieces do you have?
You have 9.
So what would that fraction be?
9/9.
Not 9/9. You're really close. We have 9 pieces.
One whole and 3.
Hold on, time out. Remember what you know about improper fractions. My numerator is always bigger than my denominator.
6/6 and 3/6.
And 3/6 and 6/6 together equal how many? 9
9 pieces.
9 pieces of what size?
The blue thing.
What size is this though? The fourths? The fifths?
The thirds.
The what?
Third.
The,
6.
the sixth. So we have how many? 9 sixths. You got it. What about, tell me about the yellow pieces. What would that improper fraction be? How many of the fourths do you have all together?
You have 6.
6 of what size?
4.
Very good. Give me one. Dang, what was that? That one hurt? Huh? You're so excited? My bad, dude.
That hurt my hand because that usually doesn't hurt my hand.
You were the one laying the skin on me, buddy.
That usually doesn't hurt my hand.
Alright, hey.
And the 8.
The 8, so how many of those do we have?
We have 12.
12.
8.
Very, very good. Alright, you have one more thing to do here, bud.
And this.
Well, tell me about that.
These are halves.
And so how many halves do you have?
2, 3.
Good job, man.
And we have 3 halves, which
Equals.
which equals this. Wait, which equals this one right there.
That's great. Alright, clip it up here on the board. You gotta show me your magnet bars, okay? I'd like for you, kind of like the last time, if you can represent your fraction and then any of the equivalents, but hey, I want you to explain it to me, okay? I want you to tell me about everything you're doing. Deal?
Okay.
Pretend you're the teacher. Cool, Dylan?
Okay. Like it's kind of like a pretending game.
Yeah, pretend you're the teacher. Pretend I'm an alien from outer space that doesn't know anything about fractions. You have to explain to me how to make an equivalent fraction, okay? Now, hold up. Time out. I see a lot more than 1.5 up there at the top.
In the holes.
Oh, okay. How are you going to represent your halves?
By using.
You need to check and make sure you have enough fraction circles to do all of them at the same time. Can you choose maybe 1 or 2 and show me how to do?
But I can't mix fractions. So move these out.
Let me ask you this, Dylan. When you represented 1.5 with the number lines, were you able to mix the fraction that represented the whole? Look, look over here real quick, Dylan.
Wait, yes.
Yes, you did, right? So you said, well, hey.
I used like kind of like ones that were holes and ones that were halves.
Exactly. So can you do that same thing?
So I'll look at
Ah,
the things on.
there you go. Go back to your number line, and you can check those.
Like,
Those are all the magnets I have, but I know that there's a few different ways that you can represent them still with the magnets that I have up there, bud.
wait. I think
That's fine. Hey,
put in this right here.
do your thing there, buddy.
Like put in this like right here. But I use first. I
Talk to me, Dylan. What are you doing there? Are you using those to represent what?
One whole.
The one whole.
And
So,
I'm going to be using these too. Like all the ones that I've used on these,
mm-hmm.
I will use.
So did you represent a whole on the number line using the 5/5? You got it, Dylan. I like what you're doing.
I'm pretending that I'm a teacher.
Good. Pretend. Remember, I'm an alien. Don't know anything about fractions. You have to tell me everything you're doing.
What did I use fourths? 2/4.
So if you used 2/4, was that to represent the whole, or was that to represent the half?
I did not use that.
Not to represent the whole. Did you use 2/4 to represent something else?
Yes.
What part?
The half.
Awesome.
Okay, what is the because I know you have enough, only enough to like use you have enough to afford. I don't know. First, you have 13 12s.
Well, that's fine. Look, I want if you can represent the. That's a great way. That's enough to represent the ones, the wholes. I don't want you to leave the center until you show me how you're going to represent the halves, though, too. Okay? Can you do that for me? Did the clip fall off of one of them? Look, go back and compare.
5, 7, 6 12.
6/12. Good job.
All the ones I'm using. Yeah.
Okay.
And you can, and I will be looking.
You want me to get it for you? You got it? All right, good job. Talk to me. Remember, I'm an alien. Don't know anything about fractions. What are you doing, teacher?
This is a whole.
Okay.
And the numerators at the top, the denominators at the bottom. But if they're the same, like if you have 5, 5, 1, 5, 5 fifths, then that makes a whole.
Okay.
One whole, one makes one whole. 3/3 makes one whole. Like all of these, if they're the same number, they make one.
And so what are you doing over here? So you're representing your one whole part, because I know you're working with a mixed number that has one whole.
But this, these are halves.
Okay.
Halves. See? 1, 2. That's a half.
So 1, 2 is a half, but what are you showing me here?
2/4
2/4 is a half.
3/6 is 1 half.
Very, very good. That's what I was confused about. Thank you for clearing that up for me, man. did it. You want to stand back and do one of these things like Vanna White? No? You want to just tell the camera that you've completed it? Oh, you gonna be cameraman? Here,
I want to be cameraman.
Let's go. Look, hit that button and you can zoom in on the work you did. There you go. What side? Where do you want it? There you go.
And zoom in a little bit more.
Zoom in a little bit more.
Wait, how do you zoom out?
This button right here. Give him a perfect shot of all that hard work he did. Go ahead. You gotta go stand there and say, "This is my work."
This is my work. And I was the one that was moving the camera and zooming.
You're a pretty good cameraman as well, Dylan. Hey, great job. Thanks for your hard
And
work.
I use these to help. And I use these to help me when I was working at the magnets.
That was a great idea, to use some of the hard work that you've done already with the number lines to help you with the magnets. Alright, Dylan. I'm gonna cut. You wanna say bye? You want to cut it?